2x to the second plus 22x plus 40. They want all zeros of the polynomial. That's the instruction. Find all zeros, including real and imaginary, all of this polynomial. Okay, so today you should have received in Canvas an email announcement from me telling you, hey, your test is next week. I'll always do that 1 week before. Here's your email reminding you your test is next week. Here's the type of skills you need to know how to do on their test. So this will probably be on there. Find all zeros of a polynomial. So as you're preparing for your test, after you've done all your homework and you're trying to really get ready, you make a practice test. You find a problem, like one from the notes, one from the homework, just like this. Find all zeros of a polynomial. Make sure you can do it in a short amount of time. That's how you get ready for a test, right? Make sure you can do all the skills in the right amount of time. All right, so let's take a look at how you'd approach this with technology, and then we can talk about what you would do if you didn't have technology. Okay, so last time we talked about the fact that if they're not giving you any suggestions on x-intercepts, real zeros, then you could begin with something called the rational zeros theorem, right? To get a list of possible rational x-intercepts. And the way that worked was you looked at factors of the constant and factors of the leading coefficient. So in this case, factors of 40, we have plus or minus 1 and plus or minus 40, of course. 2 goes in, 2 and 20, right? 3 doesn't go in, but 4 does. I'm running out of space here. 4 and 10. And then what else goes in there? 5 and 8. Okay, tiny. All right, so now what do? I'm going to divide each of those by the possible factors of the leading coefficient, which are 1 and 3. So my list of possible rational, that's what this gives me, my list of possible rational zeros, I could list it as a set. And in this set, we would put 1 divided by each of these, so that's plus or minus 1, and then plus or minus 1/3, if you divide 1 by 3. Where you have plus or minus 2, and then plus or minus 2/3. You could have plus or minus 4, and plus or minus 4/3. Plus or minus 5, and plus or minus 5/3. A lot of them, right? Plus or minus 8, plus or minus 8/3. Plus or minus 10, you get the idea, I hope. Plus or minus 10/3, I'm running out of space, so I'm going to wrap around if you don't mind. Plus or minus 20, plus or minus 20/3, plus or minus 40, and plus or minus 40/3. So in reality there, I wouldn't give you one this long on the test, so I'm going to give you smaller numbers if you don't have technology, right? But at home, in the homework, you might have some with big numbers like this. So you get a large set of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times 2. You really have 32 possibilities there to check. If you had no technology, that could take time. It's still better than having no idea where to start, right? At least it narrows it down. And we do know that we have at least one x-intercept here, don't we? Because we have an odd degree. So we're guaranteed at least one x-intercept. It doesn't have to be necessarily rational, but it will be an x-intercept. So what I would recommend if you're doing your homework and you have big numbers like this is go to technology at this point and see if one of the x-intercepts meets one on your list, because it saves you from doing synthetic division over and over again pointlessly. Okay? So on my test, since you don't have technology, once again, these numbers will be super small, so you'll be able to check that list yourself. Okay? Right now, let's go to technology. Let's see what's happening. Went to desmos.com/calculator. Who doesn't like me yet? I forgot what I'm supposed to do. 1 second. This is supposed to be